Okay, this is lesson 6.1, which is on rate of change and slope. So I have three graphs here, and if I were to say, okay, looking at this graph, which of these graphs have a constant rate of change, and how do you know? Well, when I look at this first graph and I look at the change that's happening, I see, okay, this graph is growing, it's increasing, it's representing something that's increasing, but at the beginning it's increasing slowly, and as our x values increase, it starts to grow quicker and quicker and quicker. When I look at this second graph, it's decreasing, and it decreases really quickly at the beginning, but then the amount of decrease slows as x increases. When I look at this last graph, this graph is increasing, but this graph is increasing in what we would say a constant rate, because it's a straight line, it's always growing at a constant rate each time. This one was not growing at a constant rate. It started growing slowly, and then as x got larger, it started to grow faster and faster and faster. So we're going to talk about in this chapter this type of a relationship right here, where we're talking about a constant rate of change, a constant rate of change. That's what we're going to be looking at this whole chapter. And in today's lesson, you're going to be talking about how to find a slope from a graph like this that has a constant rate of change, and from a table and a graph. Okay, so let's take a look at this, and I'm going to zoom in here. Okay, so we're going to start with just rate of change. How do you calculate rate of change? How would I calculate rate of change in this graph that I have right here, so I knew the rate at which it was increasing? So rate of change is calculated by taking your change in your dependent variable divided by your change in your independent variable. So it's dependent divided by independent. And our dependent variable, to remember that, is always your y value. So sometimes people write this change with a triangle. So change in your y divided by change in your x. So dependent's y, independent is x. So change in y over change in x. So for example, let's say you're renting a car, and this is your fee for the miles that you've driven the car. So if you drive 100 miles in a rental car, it's going to cost you $30. 150 miles, it's going to cost you $42, and so on. This represents a constant rate of change. And the way you'd figure out what your rate of change is that you would take your change in your dependent and divide it by your change in your independent. So my independent variable here is the number of miles I've driven. That's my x. And your fee is your y. So I would calculate, okay, what is my change in x? So over here, I'm adding 50 every time. That's the plus 50. On my y, I'm adding $12 for every 50 additional miles I drove. So what is my rate of change, or how much is it per mile? Well, I would take my change in my y, which was 12, and divide it by my change in my x, which is 50. And 12 divided by 50 ends up being 24 cents per mile. So that is my rate of change. For every mile that I drive that rental car, I'm being charged 24 cents. So that's how we calculate rate of change when we're looking at a table of change in y divided by change in x. Now, when I just look at the graph, like the graph that we looked at the beginning and how it was a straight line, like for instance, on this next example, I have a graph that represents the distance you might go on a motorcycle ride for a given time. So this is time in seconds. So at 10 seconds, you've gone 200 meters. At 20 seconds, it looks like you've gone 400. And so when I talk about rate of change here, you'll hear rate of change, but sometimes you'll also hear it talked about as slope. So you need to know that the slope of a graph measures the steepness of a graph. So how steep is this graph? That's what slope measures. But slope and rate of change are the same thing. It's just that slope talks specifically about, let me get rid of this right here. Slope talks specifically about the steepness of a graph. So when I look here, if I want to find my what my rate of change is, or my slope, you're going to use this formula right here, rise divided by run. So I picked two easy to read points in my graph. So I picked this point right here, it's easy to read. And how do I know it's easy to read? Because it happened to be a spot on my graph where it crossed at two grid points, where the grid marks kind of make a T. And I had another one right here. So I identify two easy to read points, and then I'm going to draw in my triangle a triangle that's going to show me, okay, I rose 100 units and I ran 5 units. And this was a positive 100 and a positive 5. So rise divided by run, rise was 100, run was 5, 100 divided by 5 is 20. So that means on this motorcycle, my rate is 20 meters per second. 20 meters per second, because I rose 100 meters and then I ran, and then my run was 5 seconds. Okay, so what I would like you to do is pause the video and try quick check 2, which is on page 309. Okay, welcome back. So on quick check 2, you had, and I'm going to move this over here and hopefully we can see this, a graph that looked like this, and you should have had 50 as your rate of change for the data in the graph. So you'd want to pick 2 easy to read points, which lots of these are easy to read points. That's an easy to read point, that is, and so on. But what you have to be careful of is that you paid attention to the scale. Some people will make a mistake of saying that they just had a slope here, a rate of change of 1, because they say, well, I rose 1 and I ran 1. That's not right, because you didn't rise 1, you rose 50 and you ran 1. 50 divided by 1 is 50, so 50 miles per hour. Okay, let's go ahead and look at points. So here's some more graphs, and I've got 2 points on here. And I want to know, okay, what's the rate of change between the point 0, 4 and 2, 1? So there's a lot of different ways you could do this, and we're going to talk about just if we use the graph. So if you wanted to plot these points 0, 4, and 2, 1, then you could say, okay, I'm going to draw in my triangle here. So those are my easy to read points. And this time to get from here to here, I would say, okay, I'm dropping 1, 2, 3, dropping 3, and I'm running 2. So my slope, rise over run, would be negative 3 over 2. So that's one way to do it. But let's say they gave you these points and not the graph. They just said, okay, I want you to find the slope of the point 0, 4, 2, 1. What's that rate of change? You could use this formula right here and plug them in right there. This formula is just like when we talked about at the very beginning, change in dependent, which is your y, divided by your change in your independent, which is x. So I could say, okay, this is my first set of coordinate points, so I'm going to call that x1, y1. This is my second set of coordinate points, so that's x2, y2. Now, could you have called this one your second and this one your first? Yup. You just want to make sure that you're labeling them beforehand and you're staying consistent. So then I just plug these points in. So I would say, okay, my y2 was 1 minus my y1, which was 4, divided by my x2, which was 2, minus my x1, which was 0. 1 minus 4 is negative 3. 2 minus 0 is 2. So you can see we got the same answer both times, negative 3 over 2, just 2 different ways of doing it. So let's look at another one like that. And ignore this red and blue for now. So we're given the points negative 2, negative 1, and negative 1, 1. So if I just plug these into my formula, y2 minus y1 over x2 minus x1, so I've got them labeled here. This was my, I'm going to call this my first set of coordinate points. So negative 2 is my x1, negative 1 is my y1. Negative 1 up here is my x2, 1 is my y2. So I plug that in. So I would say 1 minus a negative 1. But what happens when you have minus a negative? It becomes positive. On the bottom, it's x2, which is negative 1, minus a negative 2, so that also becomes positive. So negative 1 plus 2 is 1. 2 divided by 1 ends up being 2. So my slope or rate of change here is 2. Now, you could have just drawn in a triangle here. Said, okay, I'm going to rise 2 and run 1. 2 divided by 1 is 2. And it's a way to check that you did it correctly. So you can use either one. Okay, now I've also got over here this idea in red and green of what happens when you have a vertical line and a horizontal line. Okay, what is my slope here? Well, let's look at this vertical line first. So this is my vertical line, and I picked 2 easy to read points. I picked 5, 1, and 5, 2. And I did exactly what we did before. I plugged them in. So this is my x1, y1, x2, y2. So 2 minus 1 is 1, 5 minus 5 is 0. So 1 divided by 0, if you put into your calculator 1 divided by 0, what do you get? Well, you're going to get your calculator say error or something like that, because you can't divide something by 0. If I said how many times does 0 go into 1, you can't answer that question. So this right here, you would say that has an undefined slope. It's undefined. A way to think about this is like these slope, because remember it measures steepness. If this was a hill, I could ride a bicycle up this hill. I could ride a bicycle down this hill. It is impossible to ride a bicycle straight up into the sky like that. So that has a slope that's undefined. Now if I look down here at this one in green, and I pick 2 points, like 1, -6, and 2, -6, and I say, okay, this is my x1, y1, x2, y2, and I plug that in, and I say -6 minus a -6, and that became plus, so that's 0. Then I do 2 minus 1, which is 1. 0 divided by 1, well, 0 divided by 1 is 0. How many times does 1 go to 0? 0 times. So this one has a slope of 0, which makes sense, because you could ride your bike on this, and it would be easy to ride your bike on a line like that. It wouldn't take any effort. There's no steepness to it. It has a slope of 0. So what I'd like you to do is try, let's actually try Quick Check 4. Quick Check 4 on page 311. Quick Check 4 on page 311. And hit pause and then try it. Okay, welcome back. Let's try these. So Quick Check 4, the first one was 2, 5, 4, 7, and you need to find the slope. So I'm going to say, okay, this is x1, y1, oh, you can't see that, x2, y2. So what you should have done when you plugged them into your formula is done 7 minus 5 over 4 minus 2. 7 minus 5 is 2, 4 minus 2 is 2, 2 over 2 is 1. So the first slope is 1. For B, so this one has lots of negatives, so you have to be careful. So we had -1, 4, and 3, -2. So x1, y1, x2, y2. So I plug that into my formula. y2 minus y1 over x2 minus x1. Now be careful, because that's minus a -1. -2 minus 4 is -6. 3 minus a -1 becomes positive, so that's 4. And then that reduces to -3 over 2. Now the last one, C, they gave you just variables, A, B, and C, D. But this shouldn't scare you. I mean, you're just going to treat them just like they're numbers, only it's actually less work for you because you don't have to simplify anything. So I label them my coordinate points, and I do, okay, D minus B, because that's y2 minus y1, divided by x2 minus x1, C minus A. And you just leave it like that. There's nothing you can do. Okay, very quickly, I want you to look at Quick Check 5 next. There are 2 slopes of lines. This is on page 311. And I want you to think in your head as you look at these 2 lines, which one has a slope of 0 and which one is undefined. So take a pause, look at the graphs at the bottom of page 311, Quick Check 5, and tell me what you think. Okay, Quick Check 5A, that first one, that is a horizontal line. That one has a slope of 0. For B, it's straight up and down, so that one would be undefined. Okay, so that's it. If you have any questions, go ahead and watch back the parts that you need.